Hello, AP Calculus students. So we are on to the final packet, which is packet 7. I know some of you have already finished this packet, so hopefully you can use this to check your answers and it's useful. This packet covers differential equations, which I have these steps written on here already. Areas, volumes, and that's pretty much it exactly. Not much miscellaneous stuff. So a lot of this deals with basically integrals. So I guess actually I'll write that up here. We're dealing a lot in this packet with integrals, which was also the focus of packet 6, so you may find that useful. All right, so let's get started. Step 1, separate variables. So I'm going to look at this first question right here, and it is if x squared, if dy over dx equals x squared times y, then y could be what? Okay, so dy over dx is equal to x squared y. Well, then let's separate the variables. So I'm going to move the dx to the right side and the y to the left side. That turns into dy divided by y is equal to x squared dx. Cool. All right. Step 2, we're going to integrate both sides. So I'm going to copy and paste this, and I'm going to write an integral for both sides. All right. Cool. Now, well, I have to actually integrate it, so I'll do that over here. So first, I'm going to rewrite this integral of dy over y. Remember, that's really just this dy, that's just 1 over y times dy, because 1 times dy is dy, right? So I just sort of move it off to the side, right? They're the same thing. Okay. Then I'm going to integrate both sides. So integral of 1 over y is actually just ln of y, right? Think about 1 over y as the derivative. What will it be? The derivative ln of y. Integral of x squared, this is where our anti-power rule comes into play. So it's x cubed over 3, then plus c. Right, okay, you always have to include the plus c on one side of the equation because there's a constant when you integrate. So that's my step 3, plug in. Oh, don't forget the plus c. All right, step 3, I'm going to plug in my known values and solve for plus c. So let's plug in some values. Okay, well, actually, this one, they don't give me any values, so no values. Notice for these other ones they do, for this one they don't. So I'm not going to plug in any values. I am simply going to solve for y, which is my step 4. Right. So ln of y, how do I get y by itself? Well, to get y by itself, I want to get rid of this natural log. How do I get rid of natural log? Well, natural log and e are inverses. So I do e, natural log and e to the x are inverses. So I do e to the natural log of y. And if I do that, then I also have to do e to the x cubed over 3 plus c. Cool. E and natural log, they cancel out, so I'm left with just y. So it's y equals e to the x cubed over 3 plus c. But notice, however, this plus c is in the exponent, which is not normal. Usually we have a c down either as a coefficient or down over here, like plus c like that, right? So what do we do here? Well, when I'm adding c in the exponent, that's the same thing as really multiplying by e to the c. What I just erased and what I have down here, those are the same thing. E to the c can be written as its own constant. I'm just multiplying by something, right? So I'm actually going to change the c to be just something I multiply by. So I have capital C. Right? So instead of having this plus c, this constant, represented in the exponent, instead of having it in the exponent, I'm going to have it down here as a coefficient. All right, there we go. That should be my final answer. So which of these could be y? Well, which does this match with? If you look, this form most clearly matches with answer choice C here. None of the other ones make sense. The trap would be to choose plus 7 because the constant should not be here. If the plus 7 was in the exponent, that would be acceptable, but even then, that's really not normal. You should move the C down here. It should either be at ground level, plus C like that, or in front. It should not be in the exponent. All right, hopefully that makes sense. All right, next question. I am going to keep these steps written. So actually here, let me write this out. I'm gonna give a space for each step. All right, step 1, separate variables. Okay, so dy over dx, I'm gonna write the original equation, dy over dx is equal to 4x over y. So just follow along with me and you should try these each yourself too. When I separate variables, I should get y dy is equal to 4x dx. Right. When I integrate both sides, so integral, I get y squared divided by 2 is equal to 4x squared divided by 2 plus c. All right, I'm going to simplify that to just be, let's see, I guess 1/2 y squared is equal to 2x squared plus c. All right, so I just simplified it. All right, here I'm going to plug in my known values and solve for plus c. So what did they say? They said that when x is 2, my y should be -2. All right, so let's plug in those values. So I'm going to copy and paste this. He said when my x is 2, my y should be -2. Okay, let's continue solving for this. -2 squared is -4, divided by 2 is -2. That's equal to 2 times 2 times 2 squared is 4, times 2 is 8, so 8 plus c. Which means when I solve for my c should be -10, which seems a little bit off to me right now. And that's because -2 squared is +4. +4 divided by 2 is +2. So sorry, 2 is equal to 8 plus c. That means c should be equal to -6. And hopefully you can calculate for that, or hopefully you caught my mistake. Cool. So I take my original equation, and now I know my c value, it's -6, right? So I can solve for y. So let's just solve for y. In order to solve for y, I'll multiply the whole equation by 2. That gets rid of the 1/2 here, so that turns this into 4x squared minus 12. All right, then I do the square root of both sides, so y is equal to square root. I square root the y squared to get y by itself. That means I take square root of 4x squared minus 12. And keep in mind, this one's sort of tricky because remember, when I square root like this, it should be plus or minus, right? It could be plus or minus square root of 4x squared minus 12. So you'll notice my answer choices here. The only one that matches, it's going to be C or D. It's either positive square root of 4x squared minus 12 or negative square root of 4x squared minus 12. Well, let's think about this. When I plug in 2, I should get -2. That only happens for one of these, right? It has to be the one with the negative, right? Otherwise, if I plug in 2 for x here, I would get +2, which is not what I'm looking for. I'm looking for the answer that gets me -2. So my answer choice is going to be C. And you might be like, what is this x? It has to be greater than √3. Well, x has to be greater than √3 so the square root can exist. If x is less than √3, then my square root, I'd be taking the square root of a negative number. That gives me an imaginary number. So it has to be in this domain. But that's not super important. All right, hopefully that makes sense. Cool, we are going to do the next problem here. Which of the following is a solution to the differential equation dy over dx is equal to 3 cosine of 2x? With that initial condition right there. Okay, let's do that. So I'm going to erase my steps again so I can start with a clean slate. 3 cosine 2x. I'm going to separate my variables. So dy is equal to 3 cosine of 2x dx. I'm going to integrate both sides. All right, when I integrate both sides, integral of dy, you can imagine this as of 1 dy, right? Whenever dy, you can treat it as a variable, so it's like integral of 1x, integral of 1 dy. All right, integral of 1 is just going to be y, so that's sort of nice because the solve for y step seems sort of already solved for me. All right, integral of 3 cosine of 2x. Okay, so one thing to note here, obviously the integral of cosine should be sine, but there's a 2x here, so normally I would do a u substitution, right? U is equal to 2x. And you can do a u substitution, you actually should. But if I've done enough u substitutions, I know that really all I'm going to do, right? I integrated the cosine to be sine. All I'm going to do in most of my simple u sub problems is I'm dividing by the derivative of u. So I decided my u is 2x. Right, so what's my derivative of u? Well, we said du over dx. That's our next step in u sub is 2. Right, du over dx would be 2. So really, I'm just dividing by 2. So I'm bypassing the u sub a little bit. I wouldn't say being cheap, but I am taking the u sub step and sort of skipping over it. Cool, then plus c. Plug in my known values and solve for plus c. All right, well, what are my known values? I know x is equal to pi over 2, so x is pi divided by 2. Y is equal to 2. All right, so I need to solve for c. All right, so that's 2 is equal to 3/2 sine of pi. Okay, well, sine of pi is just 0. So that's just unit circle knowledge. Sine of pi is 0, which means 3/2 times 0 is 0, which means c is equal to 2. All right, c is equal to 2. All right, so I take my equation, I solve for it. I said c is equal to 2. I solve for y. Luckily, this is already solved for me. So let's just look at my answer choices. Which one does this match with? It looks like it matches with answer choice B. Cool. That one was a nice and straightforward one. Let's continue onwards. Next question. Still differential equations. So I'm going to keep this one. dy over dx is equal to ky. All right. Let f of t be the solution to the differential equation, where k is a constant. Okay, so k is just some number. Values of f for the selected values of t are given in the table above. Which of the following is an expression for f of t? All right, so I need to solve for this. I need to go back. Oh, sorry, dy over dt is equal to ky. I was like, where did the t come from? But I need to integrate and follow these steps to get to my original function. All right, so basically what we've always done, except now they gave us a table to work with as well. We'll see if that's useful. Separate my variables first. So dy divided by y is equal to k dt. Right? That's first separating my variables. All right, then I'm going to take this and integrate both sides. Notice also my k can stay there because my k is not a variable, right? It's just going to be some number. I can move it over here or I could leave it there. It actually doesn't technically matter, or it shouldn't. All right, so refresh for yourself. We already did a problem. What is the integral of this dy over y? Think about that for a moment. Okay, remember, dy over y is simply 1 over y dy. The integral of this would be ln of y. Integral of k, well, k is some number, so pretend like it's the integral of like 3. Well, the integral of 3 would be 3t, right? Because 3t, or 3 is the derivative of 3t. You're going backwards. So essentially, the integral of k is going to be kt. Then I don't forget my plus c. All right, next step. I plug in my known values and solve for plus c. Well, what are my known values? I'm given a few. I know that when t is 0, y has to be 4. So I could use that. Let's see. So So let's see. When t is 0, y has to be equal to 4. All right, well, k times 0 is just 0. So c is equal to ln of 4. All right, I can work with that. C is ln of 4. All right, so let's keep going. Although one thing I'm keeping in mind, I still don't know what my k is, and it looks like all my answers, they know what k is. So I may have to solve for k at some point, just keeping that in mind. Let's solve for y. Okay, how do I get y out of this natural log? Well, remember I put e to the power of both sides, so e to the power of natural log of y is equal to e to the power of this whole thing. Okay, cool. I'm going to copy and paste this. E to the natural log of y, that just simplifies to y. All right, e to the kt plus ln of 4. Remember, this simplifies to when I have e to the kt plus another exponent, it's the same thing as times e to that same exponent, ln of 4. All right, so this and this are equivalent. That is how exponents work, basically. All right, e to the natural log of 4. Remember, e and natural log cancel out, so it's really just 4. All right, so whatever my answer is, it's going to be y is equal to 4e to the kt. Okay, so if I look at my answer choices here, I would already actually, for multiple choice, I would skip ahead and choose A, because A is the only one where it's 4e to the k some value, right? But let's just say I wanted to solve for k. I have another pair I can use, right? So let's just see what happens to solve for k. They said y is 12. Yes, y should be 12. And t is 2. This actually allows me to solve for k. Hopefully you can see that. Right. So what happens is, let's solve for k. So that's 2k. First, I'm going to isolate k, right? So divide both sides by 4. So 3 is equal to e to the 2k. Let's get rid of this e by taking the natural log of both sides. So natural log of 3 is equal to natural log of e to the 2k. So natural log of 3 is equal to, natural log and e cancel out, so I'm left with 2k. So k is equal to natural log of 3 divided by 2. Right, okay, if I copy this k back into here, I said k is equal to natural log of 3 divided by 2. Which one does this match with? Obviously, it matches with this one, natural log of 3, and it's being divided by 2 here. So you can see how you would solve for k as well. Although since this is multiple choice and not free response, I'm definitely skipping ahead once I know the correct answer. But hopefully that was enlightening. That was a nice problem to solve. All right. Okay. Next problem. The function y equals e to the 2x plus 6x minus 12 is a solution for which of the following differential equations? All right, this is a bit different than my other problems because notice, I'm going to just refresh this because here I'm not going backwards. I'm not integrating. I'm starting off with my original answer. That's already my particular solution. I want to see which one of the differential equations does it fit. So I'm actually differentiating. I'm taking the derivatives. So each of my derivatives here uses y prime or y double prime, and then it says it's equal to 0. So let's just figure out what my y prime and y double prime are. I'm going to figure out these two, and then I'm just going to plug them in to all of these and see which one it fits. All right, first, y prime. So the derivative of this. Okay, derivative of e to the 2x would normally be e to the 2x, but this is a chain rule. There's inside 2x function. So I have to multiply by the derivative of the inside, so I'm going to multiply by 2. So it's 2e to the 2x plus 6. That's it, right? The 2 turns to 0. Okay, then we take the second derivative because I also need to use that. Derivative of 2e to the 2x would be the same usually, but I have to multiply by 2 again because it's still a chain rule. So it's actually 4e to the 2x, and that is it because the 6 turns to 0. All right, which one of these equations does this fit into? Let's just try, for example, A. So y double prime, I'll actually write this out here, y double prime minus 2y prime minus 12 equals 0. Let's see if this works. So y double prime is 4e to the 2x minus 2 times y prime, so 2 times this, minus 12 equals 0. Well, is that true? 4e to the 2x minus 2, I'm going to distribute this, so minus 4e to the 2x minus 12 equals 0. Well, 40 to the 2x minus 40 to the 2x, that cancels out. But minus 12 and minus 12, that turns into minus 24 equals 0. That does not work. What I'm looking for is something that's plus 12, right? If it was plus 12 and minus 12, then I would get 0 equals 0. And what do I see here? I see B provides exactly what I need. I have this plus 12 right here. That's exactly what I wanted. So I'm just going to go with that. That is my answer choice. Answer choice B. All right. Next one, slope fields. Hopefully you have the notes for this, but remember, slope fields, right? Each line represents the slope at that specific x, y coordinate, right? So, and then all my derivative options here, these represent my slopes, or my derivative, I'll say derivative. Actually, yeah, I'll say plug in here to find the slopes. Plug in plug into your derivative to find the slopes. Okay, so let's try an example here. Let's try, I would look at my graph here, and I'm going to plug in the point at 0, 3, and I expect my dy over dx to be equal to, well, notice at 0, 3, my line here is flat. So I expect my dy over dx to be equal to 0. So what I would do is mentally plug that in. 0 for x, 3 for y. Okay, which one of these gives me 0? Okay, when I plug in 0 divided by 3, that gives me 0. 0 divided by 3 gives me 0, 0, 0, 0. Okay, actually, all of them have a slope of 0, so that unfortunately does not really help me, right? So none of those, it doesn't eliminate any of the answer choices for me. Okay, let's just choose a different value then. I'm going to choose, let's say this looks like around 1, 1 right here. I have a slope of it's a positive slope of approximately 1. So I'm going to say 1, 1. Expect to do a slope of 1 because this is this line here. You see this line here is perfectly diagonal upwards. So I'd expect a positive slope at the very least. So let's think about that. Which of those gets me a positive slope? Boom, 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 boom. They all give me a positive slope. So unfortunately, a lot of this is just trial and error. We chose another one that's doesn't really help me eliminate any of them. Okay, so I'm just looking at these now. I think I need to get some negatives in there to actually start to iron out some of these. So I chose some points that were too easy. Let's choose one that's more out there. I'm going to try -3 right here and +3 right there. So -3, +3 for y. I would expect my dy over dx to be, I'm not really sure what that is, but I'd say relatively negative. So negative and also more negative than -1, because this is going very downwards, right? So it's going to be more negative than -1. Okay. Well, which one of these does that make sense? May have to do a little mental math here. -3, +3. So A does work. Y does not work, right? Because I would get a positive answer. I think C works, although it doesn't look, it looks almost too negative for me, but that's all right. D does not work. E does work. Okay. So Cool, I'm between E, C, and A. Let's choose now one where x and y are both negative. So I'm going to choose this point here. Also, so I'm choosing -3, -3. I expect dy over dx to be same thing. It's negative and more negative than -1. So it's like the same slope. You'll see this line and this line, they look the same. Okay. So -3, -3, A no longer works because it would give me a positive answer. -3 divided by -3 is +1. This is definitely not a slope of +1. All right, x cubed. All right, c no longer works because c would be a negative divided by a negative. That would be a positive. All right, e works, and I'll show why for this one finally. X cubed over y squared. That would be equal to -3 cubed, which is a negative number, divided by -3 squared, which is a positive number. And you'll see I get -3. That matches exactly with what this slope looks like, -3. Right, so that's sort of how you solve this. My answer choice is going to be E. Okay. Next question. The slope field for a certain differential equation is shown above. Which of the following could be a specific solution to that differential equation? Well, if you're calculating for a specific solution, one way to think about this first is you can actually, they give you the slope field with no numbers, which is sort of annoying. So you can follow this. Remember when you draw a particular solution like this, this gives you the particular solution, and you could try to see which one of these matches with your function. So for example, that does not look like the sine of x function because sine of x looks like a wave, right? This wave, goes vertical, right? So that's not right. Same with cosine of x. Ln of x also does not look like that, right? Because I'm following all the slopes. Ln of x is going to look like a logarithmic function, so it's not going to be a. Also, actually, this one's easy to figure out. 2x squared is also a parabola. You can see the function I drew clearly does not look like that. So B is the only one that works, and that makes sense for x cubed function. X cubed functions do look like this. Right, so remember, slope fields, when you follow the slopes and draw an actual graph, that is basically you drawing the particular solution. It's a specific solution to that slope field. And the slope field is basically to that differential equation. Right, hopefully that makes sense. Which of the following is a slope field for the differential equation x over y? All right, so I would think about this. dy over dx, this is sort of the same practice we did before, but let's just choose a bunch of random points, right? So x over y at, here, what do we have on the graph? They have a bunch of these 5 corners at -5 and +5 and all that sort of stuff labeled. So I'm going to choose 5, 5. Another point I want to test would be, let's try the negative. So -5, -5. Let's try these two first. All right, at 5, 5, I would expect my slope to be 5 divided by 5, which is equal to 1. And at -5, -5, I would expect my slope to also be 1, because -5 divided by -5 is also 1. All right, so which one of these at 5, 5 and -5, whoops, at -5, -5 have a slope of 1? All right, let's zoom in. Okay, clearly not A. At A, these slopes are way too big. Like this one's going way up. That is much bigger than 1. This one's going way down, so that's obviously not going to be a slope of 1. Right? It's not going to be B because this line is flat, so it's a slope of 0, so it's not B. Is it E? Okay, E is possible. This line is going diagonally upwards. It's a slope of 1. At this corner, it's diagonally upwards. It's a slope of 1. C, nope, this slope is going straight up. That is not a slope of 1. This slope is going straight down. That is not a slope of 1. All right, and D is not correct either. So actually, those were 2 great points to choose. My answer choice is going to be E. All right, next question. We dealt with the average value of a function. So actually, I'm going to write the 2 notes here. Average value of a function. All right, so there's 2 different things. Let's say they give me the position function, right? If I want to find the average velocity, that's basically saying I want the average. Velocity is the derivative of position, right? So I'm asking for the average, average rate of change, right? Okay, so that follows this equation, which we should already be quite familiar with. F of B minus F of A divided by B minus A. Okay, however, let's say they ask me for my average position. So they give me my position and they actually straight up ask for my average position. Then I'm not looking for any rates of change. I'm just looking for the average value. That is where this new equation comes in, which is 1 over B minus A times the integral from A to B of F of X dx, or in this case, X of T dt, right? So hopefully that makes sense, right? So that's why these equations are different. Don't get them mixed up. If they ask for the average value, you're using this equation and just plugging that same function in X of T here. If you are doing the average rate of change, sorry, this should also be in terms of X, you're finding the actual rate of change, so you're not doing any integrals. All right. A particle moves on the x-axis. The velocity of the particle is given by v of t. The acceleration of the particle is given by a of t. Which of the following gives the average velocity of the particle from time t equals 0 to t equals 8? Okay. Well, if the velocity is given by v of t, it's the same deal here. The position was given to us, so the average position is literally just using the position function in this equation. Well, if the velocity was given to us, then the same deal. My average velocity, which is what they're asking for, the average velocity is simply going to be me using this equation, but with velocity. So do I have that anywhere? Well, let's plug in actually from time equals 0 to time equals 8. So it's 1 over 8 minus 0 divided by 8, 8 and 0. So this is my answer basically. And my answer choice is going to be B. Right. Couple other things here. This one's close, but the absolute value bars means it's speed. So this gives you your average speed. This here, they use acceleration. This is like the trap answer. This is your rate of change of acceleration, which we don't even know the word for that, right? Because that's looking, acceleration is your second derivative. This is looking at your third derivative, basically, which is going the wrong direction. You want to stay at velocity or go from acceleration backwards, if that makes sense. All right, next question. For the continuous function from -4 to 4, the graph of f shown above consists of 5 line segments. What is the average value on the interval from -4 to 4? All right, so I'm going to take my equation. I go from -4 to 4, so b is -4, a is 4. Oh, sorry, opposite way around. B is 4, a is -4. So I'm integrating from -4 to 4 of my function f of x dx. 4 minus -4, that's 4 plus 4, so 1 over 8. And my integral, what is the integral from -4 to 4 of this function? Well, let's think about it this way. First, starting from -4, this triangle, this area is blue. right? It's blue because it's positive. I'm marking that as positive. And then when I calculate for my integral, I need to remember I'm going to calculate for this area, but that area is negative. Okay, so I'm sort of adding like 3 triangles together, although this triangle is actually cut off a little bit. So let's do this first triangle. It's 1/2 base times height. What is my base here? My base is 2. I'm looking at this first triangle right now. My base is 2. My height is just 1. Cool. Plus second triangle. And actually, it's not plus. I'd be subtracting the area of this triangle. Right? 1/2 base height. My base is 3. My height is 2. And make sure you don't mark your height as -2. Otherwise, if you do, then this can be positive because you're adding this as actual negative area with the height of -2. But I'm counting it as negative when I'm subtracting. So then I just find the height of the triangle is regular 2. All right, cool. Then the area of this triangle. So what I'm going to do is actually calculate for the area like this, then subtract 1/2 because this triangle is easier for me to calculate. So it's plus 1/2 base height, right? Because I filled in this triangle. But then I'm going to cut off this triangle, this tiny triangle at the end. So 1/2 base height minus 1/2. Okay, the base of this triangle would normally be 4. And the height is going to be 2. But then I'm erasing this tiny little triangle in the corner, so I'm subtracting 1/2. All right, they tell me here you would do the math on this, but it's 0.1875. That looks like 3/16. Exactly, it's 3/16. You would simplify this, but your answer choice should be B, right? And the trap answer, what is it? Did they include the trap answer? Nope, they actually didn't. So, oh wait, they did as 3/2. The trap answer would be if I forget this 1/4 minus -4. If I forget this, I believe I get 1.5. Yes, 1.5. But D is not the correct answer. All right. Cool. Then I'm going to keep on going to position, velocity, and acceleration with integrals. All right. So here's the deal with that position, velocity, and acceleration with integrals. The main concept is really just to remember the relationship between everything, position, velocity, and acceleration, right? And what is that relationship? Well, from position and going to velocity and going to acceleration, that's one process. Then going backwards is another process. So going forwards to velocity, that is derivatives. And from velocity to acceleration is also derivatives. And when I go backwards, that's integrals. So sorry for my poor handwriting there, but that's the core notes you got to know. All right, so a particle moves on the x-axis with the acceleration of time t, given as this. Okay. My acceleration is given as 3t squared plus 4t plus 6. The particle's initial velocity is 10. Its initial position is 2. What is the position function? Okay, so I need to take 2 integrals, right? So I'm going to take one integral. Going back to velocity, when I take my integral, I get 3t cubed over 3. This is just a anti-power rule, plus 4t squared divided by 2, plus 6t plus c. Cool. I'm going to simplify this a little bit. Actually, I'll just simplify right here. 3t cubed over 3 divided by 3. So that this turns into 2t squared plus 6t plus c. All right, what else do I know? I know that the particle's initial velocity is 10. So when I plug in 0 for t, v of 0, because that's the initial velocity that at time equals 0, I should get 10 for c. So t is 0, t here is 0, t here again is 0. Okay, if all these are 0, then and this is supposed to equal to 10, then c must be equal to 10. So C here has to be equal to 10. All right, hopefully that makes sense. All right, so then I take one more integral because I'm trying to find the position function. So when I integrate velocity, it's going to be 3t to the fourth, so just follow along with me here, plus 2t cubed over 3. Make sure your anti-power rule is fast. It's 10t plus c. All right, let's see if I can simplify this a little bit. The only thing I can simplify is the 6t squared over 2 turns into 3t squared. Excellent. All right, the initial position is 2. That means when I plug in 0 for t, I get 0 for all of these. 0 for all these t values, which means my c value here has to also be 2, right? Because remember, my position function is equal to 2. So if all these are 0, then the c at the end must be equal to 2. Okay, so I can erase all that, replace this with 2 here. And that's my position function. So let's see which one of these it matches. 3t to the fourth. Did I do something wrong here? Sorry, one moment. Oh, sorry, it should just be t to the fourth, not 3t to the fourth. Okay, I think everything else is right. So t to the fourth plus 2t cubed. Okay, so c and d are out. A, b, and e are all in, plus 3t squared, plus 10t plus 2. The only one that matches up as we go to the end is b. All right, hopefully that makes sense. Okay, a bottle rocket is shot upwards from a 10-foot stand with a velocity v of t is equal to 50 minus 1.6 t. What's the position of the velocity of the bottle rocket after 2 seconds? Okay, well, okay, so I'm given my velocity function. It's equal to 50 minus 1.6 t. And I'm going back to my position function, so I'm going to integrate it. So my position function is going to be 50t, right? Because the integral of 50 is just going to be I tack on the variable 50t. Another way to think about it is 50 is the derivative of what? Well, 50 is the derivative of 50t. All right, minus 1.6t squared divided by 2. That is anti-power rule, so that simplifies to 0.8t squared. Then plus c. Okay. The bottle rocket is shot upwards from a 10-foot stand. Okay, so that basically means my initial position is 10. So when I plug in 0, I should have 10, right? So when I plug in 0, because my rocket is starting at 10 feet. So it's equal to 50t minus 0.8t squared, so t is 0, minus plus c. So c would have to be 10 in this case. Right, so c here is 10. Okay, what's the position of the bottle rocket after 2 seconds? Okay, well then let's take my equation and let's plug in 2. Because I found my actual position equation, I solve for my c, so I plug in 2, so 50 times 2 minus 0.8 times 0.2 squared plus 10, 109.968. All right, that was obviously incorrect, and I realized I plugged in 0.2 here, not just regular 2. There we go. That gives me an actual answer of 1.106.8. All right, when will the bottle rocket hit the ground? Okay, interesting question. This is just asking, when is my position function going to be equal to 0, right? Because when the position of the rocket is 0, that means it's on the ground, right? So when is x of t going to be equal to 0? So a few ways to do this. Let's actually use our calculator for this one. What I'm going to do is take my position function and set it equal to 0 and solve for the equation. Well, how do I do this? How do I solve for any equation? Well, we have an app for that. There's an app for that, which is Solver. right? It's equal to 0. My equation is already nice and organized for me to set equal to 0. So it's 50x minus 0.8x squared plus 10. I'm going to press the green alpha button, then solve. Let's just guess where this is. Well, after 2 seconds, it's 106 feet. I'm gonna guess it doesn't hit the ground until at least like, I don't know, 6 seconds. So alpha solve. All right, negative 1.9936. Okay, so it's apparently on the ground at negative time. So it's clearly, I think my 6 seconds was not large enough. Let's guess 60 instead. So, okay, at 62 seconds, it also hits the ground. So this function hits 0 at multiple times. Apparently at negative 0.9, what was it, negative 0.019. So I had to put in a larger guess to get my correct answer, which was 62.7 seconds. It also hits 0. So you can see here, that's my answer choice E. Okay, after 3 seconds, the rocket is, first of all, to figure out whether it's falling or rising, that's the velocity, right? It tells me whether it's going up or down. So here, I'm gonna just copy this. How is it moving? So I'm gonna plug in V of 3 is equal to 50 minus 1.6 times 3. So it's clearly going to be moving up, I believe. Okay, so it's rising because my velocity is positive. So it's not A or D. Question is it rising at an increasing or decreasing rate? Well, in order to figure that out, actually, I need to, whether velocity is increasing or decreasing, I would need to take the derivative of it. So basically, I'm trying to find the acceleration. So if something is rising at an increasing rate, that means it's accelerating, right? So to find the acceleration, the derivative of velocity is negative 1.6. And if my acceleration is negative, right, that means it is rising, but it is rising at a decreasing rate, right, because my rate of change is negative. Right, hopefully that makes sense. Cool. Last section. And yeah, so here we're dealing with areas, area between curves. All right, generally there's just one sort of formula for the integration for area between curves that you need to know. It is the integral from a to b of my upper function minus my lower function. That's it. All right, identify the definite integral that represents the area of the region bounded by the graphs of y equals 4 minus x squared and y equals x minus 2. Okay, so I'm going to apply this formula, integral from a to b of the upper minus lower. The only question I have from here is, which function is the upper and which is the lower, right? Well, if you have your graphing calculator, you could easily plot that, but let's say I don't have my graphing calculator. Let's just say I don't have access to it. What I would do is, actually, which function is my upper and lower, and which is my points of intersection? What are my bounds, which are points of intersection, right? So first step, actually, I'm going to find my points of intersection. How do I do this? Well, to find my points of intersection, I set the functions equal to each other, set functions equal to each other, and solve. So let's take my two functions, 4 minus x squared. I'm going to set it equal to x minus 2, and then I'm going to solve it here. So just bear with me as I solve this. So I'm going to move everything to the right side. So 0 is equal to positive x squared plus x minus 6, which means 0 is equal to x plus 3, x plus 3, x minus 2, which means x is equal to negative 3, positive 2. So my bounds here should be from negative 3 to positive 2. Right, those are my bounds. Then I need to identify my upper and lower. Identifying upper and lower function. If they don't give that to us, well, how do I identify my upper and lower? What I often do is I can just choose a point, right? I'm integrating from negative 3 to 2. which actually, oh, that's great. Actually, if we're smart with our multiple choice, I could have probably assumed that, because look at all these answer choices. They're from -3 to 2. But anyway, to identify my upper and lower function, I'm going to choose a point between -3 and 2. Let's, for example, plug in x equals 0, right? Okay, I'm going to plug in x equals 0 into my upper and lower functions, or into these two functions. So first function, 4 minus x squared, that's 4 minus 0 squared, is equal to 4. The other one is 0 minus 2. 0 minus 2 is equal to -2. Okay, well, one function goes up to 4, one goes to -2. So which one do we think is my upper function? It's obviously going to be the one that goes up to 4, right? So my upper function is the 4 minus x squared function. Right? That's my upper function. My lower function is obviously going to be the x minus 2 function. All right, so I basically did all the work I needed to. I just have to simplify this integral to get to an answer choice. All right. 4 minus x squared minus x over 2. Looks like, okay, so I would say it looks similar to D, but the order is flipped, right? The upper and lower is flipped, so it's not D. C, they forgot to distribute the negative. It should be -x plus 2, so it's not C. So it's either going to be A or B. Looks like, to simplify this, I actually have to distribute this. I have to FOIL this out. So 4 minus x squared, so 4 minus x times 4 minus x, that is equal to 16 minus 8x plus x squared. All right. So I'm going to replace this when I FOIL it in with the 16 minus 8x plus x squared. That turns into the integral of, and sorry, I just realized I made a mistake. 4 minus x squared. This whole thing should not be in parentheses, right? It's just 4 minus x squared. Only the x is being squared. Okay, so I don't need to follow everything. I was thinking that was a lot of work. All right, so it's really -x squared. Then minus x, then 4 minus -2, so it's actually 4 plus 2, so it's plus 6. So it should be this equation that looks like it's going to be answer choice B. Matches up exactly with B. All right, you would do the same process for the rest of these. Let's go on to the next problem. All right, find the area of the region bounded by the graphs f of x equals sine of 2x and g of x equals cosine x over the interval from -pi/2 to pi/6. All right, so upper minus lower. I think we have the same problems here, right? First of all, which one is my upper? Which one is my lower? However, what are my bounds? They actually tell us our bounds, so that's nice. Their bounds are from -pi/2 to pi/6. Okay, to find which function is upper and lower, you're going to plug in a point that's in the upper function and the lower function. So let's plug in between -pi/2 and pi/6. Let's just plug in 0 again, because that is clearly between the negative and positive numbers. The upper function, or actually, I don't know which one's the upper function, but let's plug it into sine of 2x. So sine of 2 times 0. I'll tell you right now, that's equal to 0. Other function, cosine of 0. I'll tell you right now, that's equal to 1. Okay, so if one function goes up to 1, one goes to 0, which one's the upper one? Obviously, it's going to be cosine of x. So my upper function is actually going to be cosine of x. My lower function is going to be sine of 2x. Right? So I've identified my upper and lower function. Excellent. Let's integrate them. So the integral of cosine of x is sine of x minus the integral of sine of x is going to be negative cosine of x. And I need to be careful because this would require a u substitution, except if you remember what we talked about with the u substitution, if it's something simple like this, remember, I'm just dividing by the derivative of u. That's just how almost all u subs work. So really, I'm going to divide just by 2. All right. So this simplifies to sine of x plus cosine of x divided by 2. So plus, I guess, 1/2 cosine of 2x. Okay. Now I just need to plug in my bounds because I integrated. So I plug in first. I'll plug in first pi over 6 for x. So pi over 6 plus 2 times pi over 6 minus, I'll copy this whole thing, and it's pi over 2, negative pi over 2. Yes, negative pi over 2, 1/2 cosine of negative pi over 2. Cool, let's simplify this. So sine of pi over 6, that is going to be root 3 over 2. This is just unit circle knowledge. 1/2 cosine of 2 pi over 6. Well, cosine of 2 pi over 6, that's pi over 3. Oh, sorry, and sine of pi over 6 is actually 1/2. Sorry, so my unit circle knowledge was off. But cosine of pi over 3, that is also going to be 1/2. All right, minus sine of negative pi over 2. Well, negative pi over 2, that's like negative 90 degrees. That is going to be -1. Plus 1/2 cosine of 2 times negative pi over 2. So that 2 times negative pi over 2, that just turns into negative pi. Cosine of negative pi is also -1. Right, let's continue simplifying this. Okay, and we keep going. So 1/2 plus 1/2 times 1/2, that's 1/2 plus 1/4. So that turns into 3 over 4. Minus -1. So that's minus, I guess, -3 over 2. So it's equal to 3/4 plus 3 over 2. 3 over 2 can be rewritten as 6 over 4. So the answer choice should be 9 over 4. My answer choice should be 9 over 4. I don't know exactly why they wrote the answer choices like this, which is really sort of annoying, but the one that's equivalent to 9 over 4, I believe is C. Let me see. Actually, so here, I'm going to rewrite some of these. So for example, let's choose B, 3 to the 3 over 2 divided by 2. All right, it's not that one. I'm going to divide it by 8, not that one. 9. Yeah, I don't think it's actually any of these. So my answer choice should be E, actually. And I did verify this with the integral right here. My solution is 9 over 4. Sort of a weird question in terms of the answer choices, but hopefully you understand how to do it. If you're curious about when writing like this, how do I turn it into an actual answer? Remember, this can be rewritten as a root square root of 9 cubed. Right, so it's 3.375. Same thing. Okay. Next question. All right. Which of the following integrals correctly gives the area of the region consisting of all points above the x-axis and below the curve y equals 8 plus 2x minus x squared? Okay. So think about it as this way. Above the x-axis and below this curve. So my upper function, is clearly going to be this 8 plus 2x minus x squared because I'm looking, this one's on top, I'm looking below it. So that's my upper function. minus, what is my lower function? Well, my lower function is the x-axis, so that's actually just y equals 0. So my lower function is 0, y minus 0 dx. Cool. Now, the real question is, what are my bounds? Well, looking at these answer choices, looks like it's going to be some variation of -2 to 4. But let's see. Let's see. To figure out what my bounds are, you're going to take your equation and set it equal to 0, right? You set the points of intersection equal to each other. Right, so actually, I'll write that here just so I have that clear. Right, so I multiply both sides by -1, so I can rewrite this as x squared minus 2x minus 8 is equal to 0. So x minus 4 times x plus 2 is equal to 0. So x is equal to -2 and +4. Cool, so my integral is from -4 to +2. All right, this -0 disappears, so I'm looking for this integral. I'm guessing it's not going to be that easy, but let's see. All right, so -4 to +2. And it has to be this integral. So I'm first looking for this integral, 8 plus 2x minus x squared. Oh, actually, they do have it right here. So it's answer choice B. All right, hopefully that makes sense. Cool. Next question. Find the area of the region bounded by the parabolas y equals x squared and 6x minus x squared. Okay, so first thing, integral of the upper minus lower. But first thing I'm going to find is bounds or points of intersection. Points of intersection. How do I find that? I set my two equations equal to each other. So x squared has to be equal to 6x minus x squared. All right, that means 2x squared minus 6x is equal to 0. Yep, so that means 2x times x minus 3 is equal to 0. That means x is equal to 0 and 3. All right, so my bounds are 0 and 3. Okay, next, which one's the upper and lower function? Upper and lower, what I'm going to do is plug in a value between 0 and 3. So let's plug in x equals 1. Right, my first equation is 1, y is equal to x squared, so y is equal to 1 squared. That's equal to 1. Y is equal to 6 times 1 minus 1 squared. That's equal to 5. All right, so which one's the upper one? It's clearly the 6 function, the 6x minus x squared function, because that goes all the way up to 5. Okay, so my upper function is 6x minus x squared. My lower function is just x squared. All right, so next up, I just have to solve for this integral, I guess. So let's solve for this integral. First, I'm going to simplify this integral slightly. It's the integral of -2x squared plus 6x. Right? Cool. Then it's from -2x cubed over 3 plus 6x squared over 2, because I'm doing my anti-power rule. So it's really 3x squared. Then I plug in 3 and 0. So first, I'm going to take this equation, and I plug in 3. Then I take this equation, and I plug in 0. Okay, so I guess it simplifies to 9, so my answer choice is 9. You would solve this to make this nice and easy. This totally solves to 0, so I just cancel it out. Rest of this, I guess you would just calculate for that. 3 cubed over 3, well, I can cancel out a 3, so it turns into 3 squared. And that 3 cancels out. That makes it easier. Turns it to -18 plus 3 times 3 squared, so that's 3 cubed, that's 27. So -18 plus 27, you get 9. All right, hopefully that makes sense. Okay, this last section that we're going to cover concerns volumes of cross sections. And I'm going to say and volumes of revolution, right? Because ultimately, all volumes follow this equation right here. And my equation is going to be the integral from a to b of my area function itself. So whatever my area is, so actually area, yeah, of my area function. And my area function, this is the function that solves for the area of one slice, right? Slice. So in a way, all volumes of revolution, which is this next section, is really just going to be the volume of a cross section. They're all volumes of slices or cross sections. So I'll show us what I mean by this, but I'm going to go back to this simple equation where my volume is equal to this. I'm going to go back to this over and over again. The base of a solid is the region in the first quadrant bounded by the graph y equals 2 minus x squared and the coordinate axes. If every cross-section of the solid perpendicular to the y-axis is square, the volume of the solid is given by what? Okay, first of all, I know each cross-section is a square. So this area equation, that's going to be the equation for a square. So it's side squared. All right, now the question is, how do I solve for the equation of one of these sides of a square? Well, let's plot this really quick so I can show you 2 minus x squared. You don't need to know this necessarily, but it's going to look like an upside down parabola starting at, oh, actually, it starts at not negative 2, starts at 2. All right, so it looks like this. There we go. All right, so hopefully you see how that is what my function will look like. In the first quadrant, so I'm looking at only this part right here in the first quadrant. Okay, so in this first quadrant, each of these is the cross section of a square. All right, well, how do I solve for one side of this square? Well, that side of the square is defined by upper minus lower. So upper minus lower. All right, so you can see how this equation sort of evolves. So actually, I'll write out the whole sequence here. My volume is the integral of area. My area, each cross section is a square, so it's s squared. And each side of the square is determined by the upper function minus the lower function squared. Okay, cool. Let's continue that. What is my upper function? Well, my upper function in this case is 2 minus x squared. The lower function is actually just 0 because it's bounded by the first quadrant. So it's 2 minus x squared squared. Okay. Based on this, my answer choice should be D. Okay, let's go on to the next question. All right, so looking at this next question, first of all, I'm going to get my calculator out because I noticed that it is a calculator question based on the answer choices. So the region bounded by the graph y is equal to 2x minus x squared, and the x-axis is the base of a solid. For this solid, each cross-section perpendicular to the axis is an equilateral triangle. So one thing I will note, they would give you this on the exam, but the equation for the area of an equilateral triangle is square root of 3 divided by 4 of your side length squared, of your side length squared. All right. So you don't need to know that for the test or this problem, but yeah, okay. All right, so I am going to plot my function here to make it easy, just to see what it looks like. 2x minus x squared. So let's graph this. All right. Okay, so bounded by the graph and the x-axis. So I'm going to zoom in because it's this little area here, this part. So just that part, right? Okay. So what is happening there is I'm taking each one of these cross sections. If I were to draw something, it'd be a triangle here, an equilateral triangle there, right? So what is one side of that equilateral triangle? Well, again, each side is upper minus lower, like upper minus lower squared. Right, in this case, which one is my upper function? Well, my upper function is the parabola, so it's 2x minus x squared. My lower function is actually 0 because it's the x-axis, right, so minus 0, so it's just that squared. Right. Another question I might have is, what are my bounds, right? I go from a to b. Luckily, I have my calculator with me, right? My lower bound is clearly at 0. My upper bound, though, let's say I don't know how to find this. Well, I can use second trace and figure out when they actually intersect or when it hits 0, right? So left bound right here, right bound right there. My guess is that it hits, looks like it's right at 2. Yeah, at 2. So I guess my integral is from 0 to 2. Okay, cool. So I have my integral. I just need to solve this now. So let's go to math, and now let's solve this integral. Right, so math, I'm going to go to Fn integration. Remember this, root 3 over 4, I can actually move that out front. So I might calculate for that later just to make my integral easier to type. So I'm going from 0 to 2. And really what I'm doing here is 2x minus x squared. This whole thing is squared dx. All right, I'm gonna press enter to solve this. Cool, then I'm gonna multiply this. Do not forget, I need to multiply this by root 3 over 2. So times square root of 3 divided by 4. That should give me the right answer. 0.462. So my answer choice is going to be D. All right, hopefully that makes sense. Okay, next question. The base of a solid in a region in the first quadrant bounded by the x-axis and the y-axis and the line x plus 2y equals 8 is shown in the figure above. If the cross-sections of the perpendicular to the x-axis are semicircles, what is the volume of the solid? Okay, so cool. I like this problem because they use a harder equation for my area. My equation for the area is of a semicircle, so it's pi, or 1/2 pi r squared. Right, each one of these is a semicircle. And what is the equation for my r in this case? Well, actually, be careful because my equation for r is the upper minus lower. So I think for those of us who did the delta math, you will remember this, upper minus lower. But you take the upper minus lower and you're going to divide it by 2. Right, because the radius is only halfway down from the upper function to the lower function. It's only halfway down. Okay, so that is what my integral looks like. Let's fill out the rest of it. First of all, I guess what I could fill out is, what is my upper and lower function? Right? What are my upper and lower function? Well, my upper function is clearly this x plus 2y equals 8. However, it's not written well. X plus 2y minus, or x plus 2y is equal to 8. I need to solve for this in terms of y. So 2y is equal to 8 minus x, which means y is equal to 4 minus 1/2 x. Okay, so that's my upper function. All right, my lower function is just given by this line here, so it's 0. My lower function is 0. All of these have been bounded by the quadrant, so my lower function is 0. Cool. What else do I need to find? I need to find my points of intersection, A and B, right? So where do these intersect? Well, I go from 0 to, it says I go to 8 right here. So cool, they actually give me my bounds basically in this picture. So from 0 to 8. All right, so I need to integrate this. So let's use a calculator because I do not want to integrate that myself. Actually, before I use a calculator, to make this easier to type into a calculator, one thing, I'm going to move the 1/2 pi out front. So I'll just multiply after. Also, 4 minus 1/2 x, this is all divided by 2. I can simplify this to 2 minus 1/4 x. I just think this would be easier to type into a calculator. So let's do that. Math, fn integral. I go from 0 to 8 of 2. Oh, actually, I'm going to put parentheses around this first because I'm going to square everything. So 2 minus 1/4 x, I'm going to put 0.25 x. I'm going to square this whole thing, and it's with respect to x. Excellent. Then I multiply this. Don't forget, I have to multiply by 1/2 pi. So times 0.5 times, where's my pi button? Second pi. Okay, 16.755. My answer choice is C. Okay, last few questions, volume of revolutions. And remember, what did I say? Volume of cross-sections or volume of revolutions, they follow the same concept. So actually, it's not too bad because it follows the same equation where I'm integrating area. Any volume, the concept is I'm integrating area, right? So let's check this one. The region enclosed. Oh, actually, I'm going to solve that last one at the end. Suppose that the function y equals f of x is given where f of x is greater than equal to 0. Okay, so f of x is given that f of x is greater than 0, so it's above the x-axis. So above this, between 0 and 4. So let's say 4 is right there. It's above that line for 4. If the area bounded by the curves y equals f of x, okay, let's just say this is f of x. Y equals 0, x equals 0, and x equals 4 is revolved around the x-axis. The volume of revolution is bounded by what? Okay, cool. So let's just, they didn't give me an actual function. They give me this example function. If I'm revolving this around the x-axis, it's going to look like this, right? And you can imagine each circle is going to look like that. Excellent. Oh, that's actually a beautiful oval. So what is my equation going to be? I'm integrating a bunch of, each of my cross sections are what? They are going to be circles. So it's pi r squared. Okay. Well, in this case, what is the radius of each of my circles? Well, the radius is simply going to be upper minus lower. In this case, my upper function is f of x. My lower function is literally just the x-axis, so there's nothing there, f of x, right? So it's f pi f of x squared, right? Remember, I don't have to divide it by 2 here because it's not upper minus lower, and then I have to, the radius is half of that. It's literally upper minus lower. That's my radius. So same concept, but yeah, you might think about it a little bit differently. All right, your bounds were from 0 to 4. All right, so actually pretty straightforward. Which one of these integrals looks like that? It's going to be D. All right, next one. A solid is generated with the region in the first quadrant bounded by the graph y equals 1 plus sine squared of x. The line x equals pi over 2. So let's just say I have my graph here. X equals pi over 2. The x-axis and the y-axis, it's revolved around the x-axis. Okay, I don't know what this function looks like. I honestly don't. But let's just say it looks something like this. All right. So that's my y. Its volume is found by evaluating which of the following integrals. All right, let's not overthink this. Okay, so if I revolve this around, I'm not even going to draw it this time. This would be my radius, right? So My area first is pi r squared, right? Because I'm integrating a bunch of circles because I'm revolving it around. My radius depends on the upper minus lower. Well, my upper function, I'm going to count on it being 1 plus sine squared of x. Right, so I input 1 plus sine squared of x in for my radius. Okay, my bounds, I go from 0 to pi over 2, so pi over 2, 0. And that effectively is it. So which one of these matches up with that? And it looks like to me it is answer choice D. Right, and of course that's because I can move this pi out front. Cool. I'm going to pause there. These questions at the end, of course, you can Google these. You can put them on YouTube. I'm actually going to show you guys how to do this really quick so you can sort of look it up yourself. All right. Let's see. So you would look up 2010 AP Calculus AB question 4. And there's like a bunch of people that do this problem right here. The most popular one is Turksvids. I like him because he goes through the problems fast. He doesn't talk too much like I feel like I often do. But yeah, that is how you would go about solving those. Okay. One edit I made, I'm going to have us sort of right now ignore these two. The reason is you can try to solve these, but I'm going to give you hints for both of them. I actually did this one wrong. Right? Okay. Both of these, notice you are revolving it's perpendicular to the y-axis. So this square actually looks more like this. That's a terrible illustration, but everything is in terms of y. So my answer cannot be D or E, and each integral, everything's in terms of y, dy, and for whatever my area is, let's see, what area was this? It was of a square, so it's s squared. My side squared is going to be the right function minus the left function. Right, and instead of A and B, I'm going to use C and D because everything is on the y-axis now, so I'm going to just use different letters to delineate that. What is my right function? Well, my right function is still this parabola, but it's not going to be y equals 2 minus x squared because that's in terms of x. It is going to be, we have to solve for this, so it's in terms of y. So it's x squared is equal to 2 minus y. So it's x is equal to square root of 2 minus y. So that's my right function. It's square root of 2 minus y. My left function is still, my left function is actually x is equal to 0 because it's this line right here. That's my left one. So this should be my equation. And I'm going from which two values? I am actually not quite sure. Well, you would take this equation and set it equal to 0 and solve for it. So that means 2 minus y is equal to 0. Y is equal to 2. Okay, so you should go from, your integral should go from 0 to 2. All right, so it should be, oh, each perpendicular is a square. Okay, I'm going to eliminate the ones with pi. Apologies. And this is not really clean. Oh, it's going to be b because square root of 2 minus y squared, that gets rid of the square root. So then I'm left with no square root. So it should be answer choice B. All right, hopefully that makes sense. I'm going to go back. All these equations then, if they're perpendicular to the y-axis, it's the same concept, but everything's in terms of y. And whatever my equation is, it would be right minus left. This applies to the volume of revolutions one as well. Okay, so hopefully that makes sense. And that is it for today. Thank you guys.